So let's look at method 2 of real and apparent depths, and that is a traveling microscope method of determining refractive index of a liquid. So in this experiment, which step do we follow? We can start by saying that make a scratch at the bottom of a beaker and place the beaker below or under the traveling microscope. Okay? That if I have a beaker, the usual beaker we know, make some scratch that can act as our object. You can make like a cross, put a dot, but something which can be seen. And then get that beaker and place it below the traveling microscope, isn't it? Below it. So after doing that, adjust the microscope until the scratch is clearly seen, and then take the scale reading from the microscope as a centimeter. So what is true is that a traveling microscope measures the vertical distance to some level. So what happened is you should adjust your microscope not until you see the scratch which is at the bottom of the beaker. When it is clearly seen, now it is very clear. And then take measurement of the height, isn't it? From that scratch up to where the microscope is, for where you're seeing the scratch clearly. And take that reading as a centimeter from where the scratch is up to where the microscope is. And then next, fill the beaker with a liquid whose refractive index is required, and adjust the microscope until the scratch is again clearly seen, and then take the scale reading from the microscope as B. So what happened is, after you focusing the bottom of the beaker having a scratch, the moment you put liquid, what happened is the liquid will make the other mark to look like it is raised up. So now what you do you are supposed to adjust the microscope, maybe also by moving it up, so that again you see the mark clearly, because we have said that adding liquid in the beaker will make the other mark to be displaced like it is raised up. Therefore, for you to see it again very well, try to raise also your microscope up, and that will mean that the reading of B will be bigger than the reading of A. And then after doing that, we can say place an object which can float on liquid. Place an object which can float on liquid on the surface of the liquid and adjust the microscope until the object is clearly seen. And then we can say, take the scale reading from the microscope as C centimeters. And then we shall say the refractive index of the liquid is given by n equaling to C minus A out of C minus B. That is what you're calling the refract. That's why you can calculate the refractive index of the liquid. Please, this one here is standing for real depths. And this one here is standing for apparent depth. Okay? So this is where we can calculate we can determine the refractive index, because say that if I have this as my beaker, you have put a scratch, assuming your microscope is making observation from here, I will measure the height from here for the scratch as A. Is that okay? And now what happened is, if you add liquid here up to some level here, the scratch will appear to be raised to some point here. So to observe it well, that means that you should be in position of now raising this microscope to some other level here. Okay? And now that means that the height of the microscope as it's standing from the ground that it should take will now be B. Isn't it? So if the mark was here and it is here, if it comes here, it is equivalent to raising this here. So that means that this one here, definitely I would say it is the same as our displacement. Is that okay? That is our displacement. And then if you put an object which is floating here, that means that you also move this to some other level here. So that now this distance is our C. And you realize that the distance from here up to here is the same as from here up to, and this can be now our real depths. Because real depth is this. If it was here, here. If it is coming here, then this one will be raised here. This one will be real depth. So that's why we're saying that it's real depth of apparent. But now what is real depth? It is now C subtract A, we shall remain with the real depth. Now what about apparent depth? Apparent depth is now this, which is the same as now this. This is apparent depth, isn't it? This, which is this, because this is this, this is this, this is this. So if I'm looking at this being this, that means that to get this, it is the same as C minus B will be my apparent depth. So that is basically how we can determine the refractive index of a liquid using real and apparent depths and using a traveling microscope. We shall again look at using real and apparent depths, but when we are using a pin, that will be in our next coming episode. Thank you.